So this is topic 1.1, length and time. In the last session, we have already discussed about how we can measure the length. We start with, this is just a quick revision of the last session. We started with the fundamental or the basic quantities or the base quantities, which include length, mass, time, electric current, temperature, amount of substance, and luminous intensity. But you have to learn first 5 of them. Then the derived quantities, which are calculated by 2 or more measurements such as volume, density, force, energy, and pressure. The prefixes, you have to learn these prefixes like if tera 10 power 12, giga 10 power 9, mega 10 power 6, kilo 10 power 3, milli 10 power minus 3, micro 10 power minus 6, nano 10 power minus 9, and pico 10 power minus 12. And if we are carrying out or measuring the length, we can use a meter rule, we can use measuring tape, we can use a vernier caliper or a micrometer screw gauge. The most accurate one is a micrometer, which can measure up to 0.01 millimeter. When you're using a ruler, so you should avoid a parallax error. You should always look perpendicular so that you can avoid a parallax error. Same thing, if you're using a micrometer, so the formula for micrometer, that is main scale plus circular scale multiplied by 0.01 millimeter. That's a formula to get the micrometer value. So we read the main scale, this one is a main scale and this one is a circular scale. So main scale, like it is smallest value on the main scale is 0.5. So it's 0.5 millimeter, then 1, 1.52, 2.53 and 3.5. And the circular scale reading is a line which coincide with the main scale, that is a 41st. So this will be 3.5 and this circular scale is 41 multiplied by 0.01 millimeter. So when you solve, it will be 3.5 plus 0.41, which is equals to 3.91 millimeter. So this is how we use a micrometer. We place between the jaws, the object is placed between the jaws, and we close the lever and measure the main scale and the circular scale reading. This is just a quick revision what we have discussed yesterday. Now, how to measure a volume? The term volume means space occupied by the object, that is refers to volume. So if you want to measure the volume, it depends on what object we are measuring. Like example, what is the state of the substance and whether it is having a regular or a definite shape or not. So example, if we want to measure the volume of a liquid, so what you can do, you can directly use a measuring cylinder to record the volume of the liquid. So how we use a measuring cylinder, like if this is a measuring cylinder, the calibrations are there in centimeter cube, and we can have different maximum volume for a measuring cylinder depending on the size of a measuring cylinder we are using. Normally in the lab, what we use is about 100 cm3, but it can vary, it is not fixed. We can have a large measuring cylinder or a small measuring cylinder. So if you want to measure the volume of the liquid, we simply pour the liquid into the measuring cylinder, and when we pour the liquid into a measuring cylinder, how we know the value of the number? So we use the meniscus here refers to curve. So which meniscus we read for water? We always read the lower meniscus. Like the curve, this is a curvature what normally we see for water. So this is called lower meniscus, and this one is called known as the upper meniscus. So when we read, we always read the lower meniscus for water, because most part of the water molecule is down. That's why we read the lower meniscus. So example, if these are the numbers, so this was 10, 20, 30, 40, 50 and 60. So what is the volume of the liquid here, volume of the water? when we read the lower meniscus, or the bottom meniscus? So it is 50 cm cube. So we simply add a liquid into a measuring cylinder and read the volume. And when we are reading the volume, we have to avoid a parallax error. Like if I'm reading from other side, above or below, so there will be a parallax error. So these are not the right positions. So we should always look perpendicular. And which meniscus we should always look for? We should look for lower meniscus, or you can also say bottom meniscus. Both terms are used for meniscus. Here refers to the curve. So which curve we read, upper curve or lower curve? So we read a lower curve when we are recording the volume of the bottle. Is it clear? How to measure the volume of the liquid by using a measuring cylinder? So directly pour the liquid into a measuring cylinder, look perpendicular to avoid a parallax error, and always look for lower meniscus or bottom meniscus. Then if you have a regular solid, the term regular solid means it is having a definite shape. Like example, if you have a cuboid, or you have a sphere, or you have a cylinder. So if you have a cuboid, a sphere, or a cylinder, so what we use a certain formula. Like if it is a cuboid, then it will be length multiplied by width multiplied by height. If it is a sphere, then the formula for getting or finding the volume of sphere is 4 by 3 pi r cube. And if it is a cylinder, then the formula is pi r square h. That these are the formulas which we use for definite or regular shape objects. But if the object is not regular, or it's an irregular solid, like example, you have a stone or a pebble which is not having a definite shape. So what you can use, if object is not having a definite shape, then you can use a displacement method. What is a displacement method? In this displacement method, we also use a measuring cylinder. So first what we do, we fill the measuring cylinder with liquid and we record the volume. That volume is called V1. So example, when we fill the measuring cylinder with liquid, the volume of the liquid or V1 is 30 cm cube. Then we transfer this solid into a measuring cylinder, so the volume will change. This is the final volume. The final volume is coming out, example, 40 cm cube. So how much is a change in the volume when we add a stone to it or a pebble? So when we add a stone or pebble, what is the change in the volume? That is the volume of the stone. So originally the volume of liquid is 30 and the volume of liquid and stone is 40. So the difference in the volume, which is 40 minus 30, will give us the volume of object, that is equals to 10 cm cube. Is it clear? How we can use a measuring cylinder to measure the volume of irregular solid. So if it is a regular solid, a definite shape, then we use a formula. If it is irregular solid, in that case we use a measuring cylinder. And if it's a liquid, we simply use a measuring cylinder and record the volume of the liquid directly. If you have any doubt or a question, you can use your mic or you can use a chat to state that. Any doubt till now? Same thing when we are using a measuring cylinder, what precaution we should take? We should always look perpendicular to avoid a parallax error. So A is not the right position, C is also not the right position, B is the right position, and when we look from position B, we can avoid a parallax error. And we always try to read from a side, because the scale is not on the both sides, it is on one side. So if we want to avoid error, we should always look from the side where the scale or the marking, like example, even if you are looking from other side, so that is, even you're looking perpendicular but you're not looking from the side where the markings are, so that is not the right position. So you should always look from a side, because it does not have marking throughout, only one position it is having marking. So we should look from the side of the marking and look perpendicular or 90-degree to avoid a parallax error in the measurements. So these are certain inaccuracies, like the displacement method. What are the inaccuracies? Parallax error is there. The parallax error means the wrong position of eye, or student did not look perpendicular from the meniscus of the liquid. So that is also, like, he did not look perpendicular to the meniscus. He, his eye line was there, but he was not perpendicular to the meniscus as well. So that's also wrong. Splashing during immersing the rock. What happened? Like when you put the rock inside, some of the water might come out, splashing occur. So that will not be accurate. This will lead to an error. Maybe air bubbles may be found in the rock, so rock may have some trapped air, so this will not be accurate. It will be a volume of rock plus the volume of trapped air. Sometime when we use this method, instead of directly putting the rock, we tied the rock with a string. So a measuring cylinder is filled with a liquid, and when we lower this rock, we normally, instead of directly putting the rock, we use a string or a wire, which can, so the rock is tied with a string or a wire, and then we lower the rock. But what happened, what might be the inaccuracy? If we are using a thick string or a wire, then it will not be accurate. Why it will not be accurate? Because in that case there is a volume of the string as well, volume of the wire or a string. That's why it will lead to an inaccurate result. And the cylinder may not be sensitive. What is the meaning of cylinder may not be sensitive? Like the marking of the cylinders have too much difference between them. So if the marking of the cylinder may have too much difference, like example, you have here 10 is written, then 20 is there, then 30. But you don't have numbers in between 10 and 20. You don't have any number or marking between 20 and 30. You don't have any example marking between 30 and 40. So if, for example, if the level of the liquid is at this position, so it will, for you, it will not be accurate. Why it will not be accurate? Because you think it is 35, another student might think that it is 36, another student might think it is 34. So there will be inaccuracy. So we prefer to use more sensitive measuring cylinder. What is the meaning of more sensitive measuring cylinder? It means it will have greater gap between the marking, as well as all the marking should be there. Like there should be 1, 2, 3, 4, 5, 6, and so on. So when all the numbers are there on the measuring cylinder, it will be more sensitive. So these are some possibilities which leads to inaccuracy in this experiment. What are the precaution? Precaution means how we can improve the experimental accuracy, or how we can avoid the certain things to get the accurate result. So we should check the rock. It means like the rock, we can make it smooth or make it small. We should use a thin string. Instead of using a thick string, we should use a thin string. We should look perpendicular to the scale. We should look for meniscus, like the bottom meniscus, and we should put the rock gently. So actually, The precautions are the thing which will minimize the error. As you can see, like example, here it is written the first one, parallax error. So how you can avoid a parallax error? By looking perpendicular. The student did not look for meniscus, so he should look for meniscus. Splashing during immersing the rock. So some of the liquid might come out when we add the rock. So what we should do to avoid this, we should put the rock gently. The string is there which will have like a thick string is used. So how we can avoid that? So we should use a thin string. Shake the rock means like make it small or make it smooth or a regular shape. So this one is matches because some air bubbles might found in the rock. So how we can avoid those air bubbles or remove those air bubbles? By shake the rock so that it will be small, it is not able to trap any air bubbles. Is it clear? The displacement method to find the volume of irregular solid by using a measuring cylinder. Is it clear to everyone? Any doubt about the inaccuracy and the precaution? Inaccuracy means the things which are not correct or which will result in error, and precaution means the thing which we should do to avoid errors or inaccuracy in the experiment. Now we'll do some questions related to the topic which we have discussed yesterday as well as the today about the volume. But most of the topics, the questions will be related to the yesterday lesson. And I want participation from everyone. And this time your answer should be visible to everyone. So the first question is, the diameter of a copper wire is thought to be approximately 0.3 millimeter, a very small value. Which instrument should be used to obtain the more accurate measurement of a diameter of wire? I want participation from everyone. Instead of writing the option, yes, you can just mention A, B, C, or D. What about others, those who did not answer it till now? Yes, so the correct answer is C. So why C is the right answer? Because if you remember, the smallest value which micrometer can record, it can record very small value to 0.01 millimeter. A measuring tape or even a meter rule can measure from 0.1 centimeter, or we can also say 1 millimeter. Same thing is for meter rule, meter scale 0.1 centimeter or 1 millimeter. Same is for ruler, the scale which we use to draw the line on the notebook, that is also 0.1 centimeter smallest or 1 millimeter. So the most accurate one is micrometer, which can measure about 0.01 millimeter. So C was a right answer. Another question, the diagram shows a height of stack of identical coins. So there are identical coins. One coin is placed on the other. What is the thickness of one coin? Don't bother about the right or the wrong answer, and you can take your time. Like you can take about 1 minute for each MCQ or a bit more than that. The question is, yeah, I will tell the right answer, but I'm just waiting for others to participate as well. And don't bother about the wrong answer. Maybe your answer is wrong, but that's not an issue because this is not exam. This is a practice to check your understanding level related to topic. So when we check the answer, what is the right answer? The right answer is B. But why B is the right answer? Because what you have to do, you have to check the number of the coins first. They're asking for one coin. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are the 12 coins. So 12 coins having a height or a thickness of 2.4. But we need for one, so it will be 2.4 divided by 12. So when 2.4, but that will give answer in centimeter because 2.4 is a height for or thickness for 12 coins. So when it is 2.4 divided by 12, this will give you answer as 0.2 centimeter. Is there any option 0.2 centimeter? We don't find any option as 0.2 centimeter. But when we convert this centimeter into millimeter, to convert centimeter into millimeter, we multiply by 10. So 0.2 multiplied by 10, what I will get? I will get 2 millimeter. That is why B is the right answer. Is it clear? Is it clear to everyone? Okay, another question. Which instrument is used to measure accurately the diameter of a thin metal wire? So there is a metal wire and we want to measure its diameter. Which one is the most accurate instrument or apparatus? A 30 centimeter ruler, a measuring tape, a meter rule, and a micrometer screw gauge. So again, the most accurate one to measure the value, as we discussed yesterday, that micrometer is the most accurate apparatus to measure the length of the object. That's why D is the right answer. So the correct answer is D for that question. Which row shows the best choice measuring instrument to obtain the accurate value of distance shown? If you want to measure a diameter of a wire, height of the bench, and the length of the lab, what could be the best apparatus used for? You can take your time, but everyone should participate. And don't bother about the. I will give you a hint like diameter of a wire will be very small, so we need a very accurate instrument. Height of a bench, height of the table or height of the bench, and length of the lab. Length of a lab, a meter rule, maximum meter rule can measure 1 meter. So when we compare the right answer is D. Why right answer is D? Because diameter of a wire is very small. So we need a very accurate apparatus. So we need a micrometer. Micrometer, so either C will be answer or D. But height of the bench is like about meter. So we can use a, because meter rule means maximum it can measure 1 meter, and length of the lab, it is like length of a lab or length of a loop, it's any room, it is several meters. So if it is several meters, what we need, we need a measuring tape. Measuring tape, the only difference between a meter rule and a measuring tape, both have the same accuracy, but measuring tape can measure a length more than 1 meter, but meter rule can only measure a length of maximum 1 meter. That is why D is the right answer. Is it clear? But the ruler, yeah, if you are using your ruler, if it was written only ruler, that is not, that is about 15 centimeter or some 20 centimeter or maximum 30. But when we say meter rule, this meter rule means maximum it can measure 1 meter. The ruler which you are using, that is simple ruler. But if it is a meter rule, it means it can maximum measure 1 meter. Next question. The diagram shows a rectangular metal sheet close to two rulers. What is the area of this metal sheet? Area is length multiplied by width. Take your time for calculation. And when you have a physics class, physics session, you should have a calculator next to you, because there are questions, examples which are mostly related to calculation. So what could be the right answer for this? The correct answer is A. But why the correct answer is A? Because if you check, this one is 5, because 0, then for one line is there, then 10. So it means between them, it is half. This will be 15, 20, and 25. So what is the length of this side? So it is starting from 5 and ending at 25. So it means this is 20. And what about this one? It is starting from 10 and ending at 45. So 10 minus 45. So this is 35. So length of this side is 35. If you need an area, area is length multiplied by width. So it will be 20 multiplied by 35. So when you multiply them, what you will get? You will get 700 centimeter square. That's why A was the right answer for this question. Another question. A student has a measuring cylinder containing water and also has a balance. Balance is to measure the mass. Which of these could use she used to find the volume of a small metal sphere? She has no other apparatus. She's having a measuring cylinder which contains water, and she's having a balance. How she can measure the volume? So the options are either measuring cylinder containing water or balance, means either one of them can use measuring cylinder only, balance only, neither measuring cylinder nor balance. Yeah, what could be the right answer? If she want to measure the volume of a small metal sphere. So the right answer or the correct answer is B. Why B is the right answer? Because balance, the purpose of the balance is to measure the mass. So even it's a regular object, and if we don't have, because if we have a sphere, so what we can do if we need a volume of sphere, so the formula to get the volume of sphere, volume is equals to 4 by 3 pi r cube. That is the formula for volume of sphere. But we don't have we cannot measure the radius or diameter because we don't have any other ruler or a micrometer to measure the diameter or the radius. So we cannot use the formula. Then what else we can use? We can use a displacement method. What happen in a displacement method? We'll take a measuring cylinder and we will fill this measuring cylinder with liquid. And we will add the sphere. So when we add this sphere, so the volume of the liquid will change. So as the volume of the liquid will change, this volume was V1, this volume is V2. So the difference in the volume, which is V2 minus V1, will give us the volume of sphere. So this can also be done if we don't have an apparatus which is required to measure radius or diameter or height. So we can use this measuring cylinder to get the volume of small sphere. So the correct answer for this one is B. Another question, the diagram shows a solid rectangular side block. The diagram 2 shows the same block from front and from side. A meter rule have been shown close to the edges. What is the volume of the block? Volume is length into width into height. Yeah, what about others? So when you check the answer, the correct answer is B. Why B is the correct answer? Because the volume is equals to length, width, and height. This is the front face. This is the front face. So it is starting from 1 and ending at 5. So this is 4. Then this is starting from 4 and ending at 11. So this is 7. And the side, it is starting from 5 and ending at 21. So it is 6. So length, or if this is 6, this will be 6 as well as this. So length, width and height, when we multiply them, 4 into 7 into 6, what we will get? We'll get 168 centimeter cube. How the height is 4? Because it is starting from 1. When you check, it is starting from 1 and it is ending at 5. So starting from 1 and ending at 5, so this height is equals to 4. Is it clear to everyone? I'll continue this discussion and share another link.